Hi, everybody. This is Rajkumar Sen. I'm the founder and the chief architect at Blitz.io. Uh, at the very start, I would like to thank the organizers of the Distributed SQL Summit 2021 and the folks at Yugabyte for having me, present this at the conference. And thanks so much to all the attendees, for listening to this talk. We hope it's a good and interesting discussion for all of you. The title of the talk today is fulfilling the data modernization dream by serving continuous data replication with a distributed database. And we'll talk about how to modernize your data infrastructure, using a combination of distributed database and CDC-based continuous data replication. So if you look at the evolution of databases from 1980s to 2020, we started off with 4 or 5 databases, which were pretty much first generation, Oracle, DB2, Sybase, Informix, SQL Server, but all of them had some advantages, and they all played their role. Um, However, they're on-prem. Most of them had monolithic architectures. They all had relational data model. Mostly the deployments were single node with 1+1 HA, and the way customers would use them would be, enterprises would just select 1 or 2 apps, 1 or 2 databases, and write most of the apps on them. So that was all that we had. And then how's it going now? 2020, we have so many systems, that are crafted for the various use cases, and there is on-prem choice. You would go for fully managed cloud offering. There are diverse data models. SQL is obviously the most popular, and something that I personally like the most. But there are no SQL databases popular. People are using GraphQL interfaces on top of databases. So there's obviously a lot of choice now. And yeah, of course, we have finally distributed relational databases like Yugabyte and CockroachDB and Cloud Spanner. However, in this decade, we believe that enterprises should be able to select the database best suited for the app, and not build everything on the same database where the data is stored. So there should be definitely data democratization and data socialization. Enterprises are going through this digital transformation exercise, but the digital transformation dream won't be fulfilled unless you can modernize and democratize your business data. If you're stuck with your legacy architectures, then you are going to have some massive problems. Some of these are highlighted in this slide, but there are like tons of other problems. Of course, we know that systems like DB2, IBM, they come with tremendous amount of cost, not only of the way licensing works and all of that, but in terms of they're difficult to manage. You need an army of people to manage the systems. It's because of non-distributed architecture. These are all fragile and have a lot of downtime. We have seen horror stories of how these architectures have failed in giving 24/7 um, availability to their customers. And because all these systems are legacy, people don't want to build on these systems. There's a lot of, it's very hard to change because developers are not very keen on writing apps on these legacy architectures. Uh, Distributed open source databases solves most of these problems. If you look at cost, there's a lower TCO that is true for most of the open source distributed databases like Yugabyte, CockroachDB, and the likes, because the licensing model is different. The set of people that you need, the set of DBAs, developers, DevOps, whatever you call it, the set of people that you need, they're they're interested more in working on these kind of systems. So there's obviously a lower TCO, and I believe that's the way to go on reducing your cost from the legacy systems. But most importantly, we can see that there is the biggest benefit of all of this is there's no downtime now with these distributed databases that can deploy that give you multi-location geo-distribution, self-healing, and all those nice properties. You're not limited to a data center failure. You're not limited to a single shard failure. All those problems are gone, and you have like tremendous amount of data availability by open source system. The third most critical thing is, the developer productivity would just go on a massive, rise. With if you start building your apps on these open source databases, people are building on Postgres, on MySQL, and the likes. And with a product like Yugabyte as an example, which is built on top of Postgres, and you just get all the Postgres developer community would want to build on something which is like Postgres, and has all the feature richness of Postgres. So overall, if the way we think that data modernization should happen is, you have to move and transform your data from this legacy architectures, like Sybase, Oracle, to modern cloud native architectures. um, and also, there's a data democratization step there, which is data actually needs to be mobile. And data should be able to travel to any platform of choice. If an app desires that the app is best suited to be developed on a particular platform, data should be traveling to any platform of choice. There should not be any silos in any organization. We've seen that Amazon was very successful in its attempt, and after 7 years of struggle, it was able to turn off its final Oracle database. Based on the data available on the internet, it seems there was a rack cluster which had petabytes of data, and via multi-year migration process and a complex data model rewrite, um, Amazon was able to migrate all its databases from Oracle to a combination of Aurora, DynamoDB, and even Redshift for some of their analytical workloads. But the important thing to notice from the Amazon migration was that they had very little or no downtime migration. And that is because Amazon, as you know, like it's a 24 by 7 operational shop. You really cannot afford any your meaningful downtime for any of your database migration or modernization efforts. Question is, can everybody, can every enterprise repeat this exercise, or is this let's look at how we should think about this. I like the Amazon idea. I'm a big fan of the company, but I'm not a big fan of the fact that some of the relational model went to something which is NoSQL. In general, it's not very clear when you break down a relational schema to a NoSQL schema. What are the implications of that? At times we have seen that those implications are far-reaching and add more stress to your app developers. So, I think enterprises should look at modernizing and democratizing data with minimum impact. And what does that mean? That means you should retain a relational data model as far as possible. You should select a feature-rich distributed SQL database to build, or migrate your apps, and you can keep building your new apps on the new system, and alongside migrate your existing apps, from the legacy systems. But the critical part here is that you can migrate with little or no downtime by keeping both systems in sync, which is what Amazon did over a period of 7 years. So only by keeping both the systems in sync, and and in transactional consistent data, you can keep moving your apps from the source to the target with little or no downtime. So what does it mean, to keep systems in sync? So the traditional way in which homogeneous systems were kept in sync, especially if you look at the previous generation, Oracle, Oracle slave, primary, secondary, all of that was powered by what we know as the CDC, change data capture technology. So CDC is the technology that allows us to pick up transactions from the source system, transform the data to the target system, and apply the transaction at the target. So the way to keep both the transactional systems in sync is to do continuous data replication. From the legacy systems to a modern distributed database. And in this case, we just chose Yugabyte as an example, um, because of the feature richness of Yugabyte and the fact that it qualifies as the modern cloud native database. If you use a native cloud native CDC technology in between, you should be able to get guaranteed transactional integrity, which is of course, if a transaction shows up in the source databases, you would like to get it and apply it in the target, not lose data, not have duplicates in um, all the good stuff. And of course, being an enterprise solution, there should be an ability to repair and replay transactions. Things go wrong during replication, so you should be able to repair and replay. Most importantly, you should be able to handle DDLs to the best possible extent. uh, DDLs are complex to handle. uh, However, any good data application solution should be able to handle DDLs. um, some form of bidirectional replication should also be provisioned, because people may want to move some data back to this a legacy system for a brief moment of time while the migration is going on. So what are the properties of a cloud native CDC solution, right? So the first property, obviously, as we described, right, it has to be, it has to provide transactional integrity, and the second property is scalability. You want a solution that could scale if based on the data volume and velocity. And then obviously the most important item for any data replication solution is a solution that has very low data latency and minimum impact on the source. So and as I mentioned before, data in target should be transactionally consistent with the source. And for most OLTP systems, we should maintain the global order of transactions as a source. Um, Scalability is very, very important, because the a modern distributed database gives you the ability to absorb and ingest a lot of data at high volume. So naturally, the CDC solution should also be able to extract and load data at high volume and velocity. And regardless of that, any modern solution should be able to scale up and scale out, especially for cloud-based deployments. Auto scaling is a necessary feature that every cloud native property should cloud native product should have. The other aspect on the data latency is obviously that any such solution should have minimal impact on the source. Any CDC solution should not be impacting the performance of the source database. So I'm presenting you a architectural idea, which is we termed it as a global system of access. Let's look at what it means. So imagine you have a set of system of records, which databases, which could be SAP, IBM, Oracle, SQL Server, DB2, and let's pretend that we have a great cloud native CDC, distributed CDC platform that that is able to do transactional um, replication to a globally available distributed database. So if you can consolidate using continuous replication, if you continuously replicate all your legacy data in a global SQL database, then you could do certain interesting things, which is you can retain your legacy system as the system of record, till your existing apps are rewritten. but you can use the new global database as your system of access. So what does it mean? It means that any reads that you do of the database, and what we call as the data consumption consuming apps, any reads that you do can just run on the system of access here, because as I mentioned before, this is a transactionally consistent replica of the source databases. So you can actually run all your reads on this global system of access. So with this, you can actually offload all your reads from the system of record to the system of access, reduce your cost on the system of record, and you can give your developers the choice to build now on this modern Postgres compliant API. So it's like a win-win for everybody. It's really a data modernization at scale idea, because with a distributed database like YugabyteDB, what you get is that instead of data being available in one data center or two data centers like legacy systems like Oracle or DB2, you actually have your data availability now across geographies, across data centers. There is no more cross data center redirects, as you know, with previous architecture. If you are a user in California but the data is sitting in Virginia, you would be just redirecting the data to some data center. But those problems are gone with modern systems, and most importantly, you're just opening up the data for all your developers who are the next generation, want to actually build on this modern architectures, right? um, and you also have the flexibility at deployment flexibility, because you can deploy on-prem, you can deploy on the cloud, you can do hybrid cloud. So there's so much flexibility in all this, and you're really looking at a very thoughtful data modernization experiment here, which is at scale. And we believe that this is a fantastic model to just consolidate all your business data in a risk-free way, and still increase the developer productivity. Uh, I'm going to present you an example for banking, which Blitz has actually implemented, recently, where the customer data is spread across two systems of record here. One part of the data is in Oracle, which stores the less frequently changing data. So let's say a customer has name, address, SSN, their bank statements, loans, credit score. These things keep changing, but they're not that frequently changing. So some of those data was stored in Oracle. Then the DB2 mainframe was the part where was the system where most of the actual customer transactions was stored. So a combination of the DB2 and Oracle data would be the actual system of record information for one customer. And then in the target global system of access, you could have a consolidated schema. You could have one-to-one relational mapping of all your tables in one database. And each of these tables are can be kept transactionally consistent with Oracle and DB2. And of course, because we're doing heterogeneous replication, and naturally there's a predefined latency of few seconds, that is naturally expected when you move data across. But if you look at it, every transaction from the source would be picked up, and would be pushed to the target by maintaining the global order. So even let's say on the Oracle side, a bank statement got refreshed, then that data can be picked up and moved. And primarily, if the customer is transacting very often, then that data can be picked up, and moved to the target system here. Um, Modern system of access would entail a bit of app rework. If you already have an app, that's in vogue. So there are opportunities to to do some rewrites here. In this case, because it's a banking application, core apps within the bank, which are not the most high volume apps, so they would continue to use the existing system of record for reads, writes, everything. However, new apps, which actually have much more usage, which is like the mobile banking app, which obviously, if you look at how many users are there in the mobile banking, there would be like several orders of magnitude higher than the users within a bank, or third party banking, browser, desktops. They could benefit from a proxy, where the proxy actually now would redirect reads to the system of access and writes to the system of record, which means the proxy has an intelligence with the app that it knows whether um, a particular session should be redirected to the system of access, or whether a particular session should be redirected to the system of record. So let's look at it in a little bit of a detail. Okay, let's look at the application of the proxy interface here. So if you look at the application that sits on top of the proxy here, and all the connections go through the proxy, and the proxies will actually going to identify whether this current session, or in the queries that's part of this session, are they modifying or mutating any data. So if they're mutating any data, then based on that, the proxy would redirect it to the existing system of record, and and based on logic, whether it has to go to Oracle or DB2 to do its job. But if they reads and selects, naturally, that piece of access comes to the global system of access. And there's a reason I have put this arrow to be having indicate that there's much more data that's traveling in this channel. That's obviously because if you look at any banking application, whether it is core banking or mobile banking, it naturally, it's if it's 80% reads and 20% writes. So naturally, most of the data here would be of the read category, which is then benefiting from coming to a global system of access, which is not only more modern, but also globally more available. So this is an architecture that is can resonate with various different app verticals, just not financial application. And I would really encourage the listeners here to think about this kind of architecture, especially with a modern database like Yugabyte here. With this, I would like to conclude my talk. Thank you all for listening in, and I am open for questions. Thank you so much again, the DSS team and the Yugabyte team. Thank you.